All right, guys, today we're going to be learning scale drawings. So first step is to go ahead and get the formula. So again, we are using proportions. So you guys are going to become complete and total experts at proportions. So on your notes, the top box says formula. So our formula for scale drawings is model over actual. And model over actual is going to equal the scale over the scale. So for example, scale drawings, examples of scale drawings include blueprints, maps, sometimes figurines, things of that nature. So it's drawn or created proportionally to the actual object. So for example, if you look at the blueprint of a house or of your room, your bed in the blueprint is going to be larger than your dresser, right? And you will be able to figure out how much space you would have to walk around the bed or something of that nature because it's drawn to proportion. So let's say, for example, you have a drawing and it's for every 1 inch, it's going to be maybe, 3 feet. So your drawing or your blueprint would always go on top and the actual dimension would go on the bottom. Another example is a map. So on a map, you would be able to tell the distance from, say, here to Dallas and then here to Mississippi or something and say that, okay, it's 3 times as long, so it's probably going to take me, or 3 times as far, so it'll probably take me 3 times as long. And then you'll often be given the scale written like this. It'll say 1 inch to, or with the word to, 3 feet. And that's often how you'll see the scale. So you're always going to put the first dimension, because that's always the drawing, that's going to go on top, and then on the bottom is going to be the second dimension, or the actual. So make sure all of this is in that top box of your notes before you move on. All right, so let's just go right into an example. And get a different color. So it says, if the scale is 2 centimeters equals 25 meters, what is the length of the missing measurement on a scale drawing given an actual length of 150 meters? So we're always going to write drawing over actual. And to help us out, let's look at our dimensions. So we're looking at 2 centimeters and 25 meters. So I'm going to put centimeters on top because they're going to stay on top, meters on bottom. So making sure we're including our word ratio with our scale drawing calculation. So this scale, I'm always going to write that on the left side of the proportion. So what they say the scale is. So it says 2 centimeters, it's the drawing, it's going to go on top, 2 centimeters is equal to 25 meters. So then it says, what is the length of the missing measurement on the scale drawing? So we want the length of the missing measurement on the scale drawing. The drawing is on top, right? So that's X, given an actual length, oops, my battery is running low, of 150 meters. So once we set the proportion up, you guys know where to go from there, right? We go ahead and do our cross product. 25x equals 2 times 150. Oopsies. 2 times 150 times 2, which I know that 2 times 150 is 300. Divide both sides by the number directly next to x. And let's see, 25, I know it goes into 100 4 times like quarters, right? So there's 4 in 100, then there's 8 in 200. So 8 plus 4 is there's 12 in 300. So x is 12, and we want to make sure we label it. So x is 12, and the x is on top, so 12 centimeters. So the length of the missing measurement on the scale drawing is 12 centimeters. Okay, so now we have the first example done. Let's move on to the next. So if the scale drawing is 1/4 inch equals 15 feet, what is the actual measurements for an item that is drawn as 9 inches? All right, so I'm going to circle my scale. Oops, let's go ahead and write our word ratio. So it's always going to be drawing over actual. And let's go ahead and label our measurements. So it says 1/4 inch. Remember, we said the first one always goes on top, so inches on top. And then the second one goes on the bottom, feet on the bottom. So drawing over actual, inches over feet. Now I'm going to set up my proportion. And my scale is always going to go on the left side of the proportion. So 1/4 inches is equal to 15 feet. So what is the actual measurement? So actual is top or bottom? Bottom. If it's drawn as 9 inches. So inches and drawing is on top. So 9 inches. All right. You guys know the drill from here. We're going to do cross product. You guys don't like fractions. So can we change it to decimal? So 1/4 is like 1/4. So 25 cents. So 0.25. X equals 9 times 15. 9 times 5 is 45. 9 plus 3, or 9 plus 4 is 13. So 135. You always divide by the number directly next to X. I don't know why it keeps doing that. Sorry. There we go. All right. These cancel. So X is going to equal 135 divided by 0.25. Well, there's a decimal point on the outside, so I have to move it twice. Do the same on the inside. 1, 2. Add my zeros. Raise it to the roof. Go ahead and divide. 25 does not go into 13, so it needs to go into 135. Let's see. Goes into 100 4 times, and then if I add 25 to that, so 5 times 25 is 125. I get 10 and I get 100. When I bring down the 0, 25 goes into 100 4 times. I get 100 and I subtract and it's 0, but I'm not quite to my decimal, so I have to fill it in with a 0. So X equals 540. X is on the top or the bottom? Bottom. So what is the measurement? It's going to be feet. So the actual measurement was 540 feet. All right. Nice job, guys. Let's do another. On a map, 1 inch represents 20 miles. If the distance between Atlanta, Georgia and Nashville, Tennessee is 12.5 miles on the map, what is the actual distance between the cities? So guys, this is just a different way to say scale. 1 inch represents 20 miles. So we're going to do map or drawing over actual. In this case, the map is inches over miles. Write my proportion. I always put the scale on the left. So 1 inch over 20 miles says if the distance is 12.5 inches on the map, 12.5 inches on the map, so map and inches go on top, what is the actual distance? X is on the bottom. All right, you guys go ahead and press pause and solve it. Okay, so let's just discuss. So what are blueprints? Have any of you guys seen blueprints before? So blueprints are a plan that kind of lay out a design and the implementation. And the reason why blueprints are important is so that not only can you see the look, but you can see what kind of materials are needed. You can save on costs, right? So you don't order the wrong things. You can see if certain things will fit. So it's really beneficial. My parents had a pool put in and they already had a pool, but they had it fixed. And So they had blueprints done, or when we designed a house or something like that. You know, an architect uses blueprints to not only make sure that the structure is sound or that the structure can stand, but that it looks nice and that they have the right supplies for it. So go ahead and write your responses for these two incomplete sentences. Okay, here are some examples of blueprints. So here is a building. They do it for shoes, purses, handbags. Here's houses and vehicles. So blueprints are used all the time. Engineers, especially architects, mechanical engineers, they all are very familiar and use blueprints on a regular basis. All right, so let's go ahead and check out this next piece. So we have this table here, and we need to go ahead and use the scale to find each of these dimensions. So again, scale is drawing. Oops, sorry, it's hard to see that color. So drawing over actual. And in this situation, we're going to use the same scale for each of these problems. So it says that the scale is 1/4 inch. So I'm going to put inches on top over 15 feet. So feet on the bottom. Going to go ahead and set up our proportion. So it's saying 1/4 inch. So we know that's on top is equal to 15 feet. So you're going to write this proportion for each one and solve them. So for example, so if I just keep writing these proportions to, this one is 1/4 inches over 15 feet. So if we were going ahead and doing number one, 9 inches, right? Inches are on top, so 9 inches over x. Cross product and solve, or say we're doing 12 inches, right? So 12 inches over x. So you guys know how to set it up. Go ahead and press pause and finish your table. All right, guys, so we're going to do the same thing that we did on the last one and apply it here. The difference is they're giving us the actual. So again, we're going to write drawing over actual. And if we look at our scale, it's saying centimeters over meters. So the scale they gave us was 2 centimeters is equal to 25 meters. So again, I'll help you set up the first two. I'm repeating my scale because we're using it for each one. So the first one up here says 150 meters. So that's my actual. Meters goes on the bottom, 150 meters and x. And then let's take a look at the second one. It says 475 meters. So x and 475 meters. So use your cross product and solve. All right, guys, last one on your own. I think you've got it. Picture has 14.5 inches. It's dilated, which means it's getting, think about your eyes being dilated. It's getting bigger by a scale factor of 2.5. What is the side length? So 2.5 over 1 is going to be your dimension. So picture over actual. Inches over, let's see, what is the length? All right, so it's 2.5 over 1. So you're just going to multiply these two. All right, guys, do it on your own, and nice job today.